So this is 11.2. And the two sample Z procedures that we use in Chapter 10 are going to compare proportions of successes in two populations for two treatments. What if we want to compare more than two samples, or two groups? More generally, what if we want to compare distributions of a single categorical variable across several populations? We need a new kind of statistical test. This new test starts off by presenting the data in what they call a two-way table and examining the conditional distributions. Basically, that means finding the proportion of each part. Example number 1. In an article in the Journal of American Medical Association called JAMA, reports the results of a study designed to see if the herb St. John's wort is effective in treating moderately severe cases of depression. There were 338 subjects who were being treated for major depression, and the subjects were randomly assigned to receive one of three kinds of treatments: St. John's wort, Zoloft, or a placebo. Zoloft is a very popular antidepressant, for those of you who don't know. For an 8-week period of time. The table is summarizing the results. So the first thing that we're going to do is we're going to calculate the conditional distributions in proportions, meaning decimals, for the types of responses for each treatment. So first of all, let's say we were talking about St. John's wort. In St. John's wort, there were 3 of them. There was 27 out of 113, which is the same as 0.239. There was 16 out of 113, which is the same as 0.142. And there was 70 out of 113, which is the same as 0.619. For Zoloft, there was 27 out of 109. So these are each of the conditional probabilities. This is 0.248, or what they call marginal. There was 26 out of 109, which is the same as 0.239. And there was 56 out of 109, which is the same as 0.514. And then for the placebo, there was 37 out of 116, which is the same as 0.319. There was 13 out of 116, which is the same as 0.112. And then there was 66 out of 116, which is the same as 0.569. So these are what they call the marginal distributions, or marginal proportions. And we're going to be using this number later, but 338 is the total number that we'll be looking at for the table. In the next part, we're going to be talking about an appropriate graph for all of this stuff. And so we're going to use a bar graph, since it's categorical data. And in my bar graph, what I'm going to do is I'm going to talk about St. John's. I'm going to talk about Zoloft and the placebo. And we know that if we're talking about the distributions here, we want to talk about having 100% of the data being represented. And so I'd break this up, maybe here's 50, here's 10, 20, 30, 40, 60, 70, 80, 90. And based on what we have here, we're going to be talking about, like for St. John's, for example. I know that in St. John's, out of the whole 100% for St. John's, that part of that was up at the top here, what they called a full response, a partial response, or no response to the treatment. So I'm going to do each one of those. So if I'm looking at St. John's and I talk about what they had for a full response, we got 24% roughly. So here's 20, here's 5, so somewhere right around here. This is a full response. So maybe off to the side here, I should use a color coded. This is a full response. And if I was doing this for Zoloft, Zoloft had, roughly the same, just under 25. So here's Zoloft. And for the placebo, the placebo had 32%. So maybe somewhere right around here. It looks like I went too far with those other ones, so let me just fix this a little bit, sorry. And then the next part would have been, well, what about then for their partial? So in St. John's, if I use a different color for partial, there was an additional 14% for St. John's, so that would put me totally at 38 roughly percent. If I put those two together, because 24% and 14%. And then for Zoloft, that was another 24%, so now I'm at 49. And for the placebo, there was another 11%, so that's at 43 roughly. And then the remaining was no effect. So I can go with the remaining, or in other words, no effect. I think that's what they use, right, for the word no response. No response. And that'd be the remaining. And so this bar graph set up here talks about it. And then probably down below here, I probably should have wrote down, since I did the labels up the top, these are the percentages. When looking at part C, when it says compare the distributions, you're looking for kind of unique features. And I guess for me, something that sticks out is the placebo, maybe surprisingly, the placebo had the highest partial and full response total.
No, I didn't.
No,
Just part, just full.
Just full.
Combined.
Nope, no, because look at the bar graph. Looking at Zoloft is highest.
Oh, just full, you're right. Sorry, my bad. All right. Well, I'll amend that. I apologize. Highest full response total. That's kind of weird if you think about it, if you're getting medication. And then, I guess, I would also say Zoloft had the highest total response to the drug, to the treatment, I guess I should say, which was the full or the partial combined. But to me, the most surprising is that the placebo had the highest full effect. So notice how we're trying to, in the previous problem, compare the distributions of a categorical variable in 3 different populations, or treatments, in other words, St. John's, the placebo, and Zoloft, in order to see if our results are significant. And we want to perform a test. So you start with null and alternative hypotheses. These are very similar to what we were doing previously, where we say in our null hypothesis that the status quo would be that there are no differences between the treatments, and then our alternative would be that there are differences between our treatments. So for our example problem, what we would say is something like maybe HO, there are no differences in the distributions of responses for patients with depression when taking St. John's wort, Zoloft, or the placebo. And then, of course, your alternative hypothesis is saying that there is a difference. Same information afterwards. Now, when we use tables, one of the things that's really important, you remember from our dice problem yesterday and the other problem that we had, when we're finding this chi-square statistic, it's really important to be able to talk about something called the expected value. When they use tables, they talk about the expected count. So the most important thing today that's kind of unique is this formula that's right here. And that's how you find the expected count. And basically you take the row table times the column table totals and then divide by the total table. So the thing that's going to be really important later on is this, oh darn it, is this 338 number when we're doing this. So as we go along, I'm going to be using that 338 to divide every single time, just so you know. So knowing that, what I want to do is I want to find the expected counts for every single one of these. So we have, it's kind of like a two-way table, but with the expected values, or the expected counts, I guess we'd say in this case. So as I do this, I have full response, partial, no, and then St. John's, Zoloft, placebo. So I'm just going to go with FR, PR, and NR for the responses. And then we have St. John's wort, and we have Zoloft, and we have the placebo. So as I find these different things, if I look at, for example, St. John's wort, and I was talking about its full response, I'm looking at St. John's wort one way, and then the full response the other way. So I'm looking at the 91 and the 113, and then the blue number.